In this video, we are going to review exponential functions, which we did very recently, so it should not be that difficult for you guys. It's a quick, easy lesson today. So in an exponential function, we have multiple words that we need to know when looking at a graph. So the first thing is that this line is going up. So therefore, this is a growth. This exponential function that's modeled is a growth. The initial value of an exponential function is the number where it touches the y-axis. So in an exponential function, the initial value is the y-intercept, which is 4. The next word that we need to know is the asymptote. The word asymptote has a y in it. So in Algebra 1, we write our asymptotes as y equals. So now, underneath my graph, there you go, good enough, is a line. So the asymptote is an invisible line that sits right underneath your graph, and it keeps your graph from dropping below that line. So in this one, this graph never drops below the number 3. So I have an asymptote at y equals 3. Just like in yesterday's function, the domain is that the x goes forever to the left and forever to the right. So the domain is all real numbers. Now my range is where my y's live. So if I look at this graph, there's no y values down here. All of my y's start at the number positive 3, and they're all above the asymptote. So in this one here, all of my y's start at the number positive 3, and then it goes up forever. So it's not greater than or equal to. It doesn't touch the 3 because there's an asymptote there. So it's just everything greater than 3. Let's try that one more time. So in this one here, this is a decay because it's dropping down. This is the graph of a decay. The initial value is the number it touches the y-axis, which is the number positive 1. My asymptote is where this graph does not go below. Asymptote has the letter y in it, so it's a y equals. This asymptote is that it never drops below 0. Just like earlier, domain is left to right. Arrow on the left, arrow on the right. It's going to go forever, so it's all real numbers. Range is y. None of these y's live below 0, so they're all above. Ugly sign, sorry. All of my y values live above the number 0. Very easy. Okay, I want you guys to try 2 of those on your own. So the next one, is it a growth or a decay? If it's dropping, it's a decay. If it's going up, it's a growth. We always read graphs like we read a book, which is left to right. Growth or decay, growth or decay. Easy. Initial value is where it crosses the y-axis. Asymptote is the horizontal line that it doesn't drop below. Okay, so once you have those 2, let's move into some word problems. These word problems are very easy though. So in this here, we always have a starting value. So we're going to figure out where this thing starts. In math, another word for starting is the word initial. Then we have the next one, which is my multiplier. And then it's raised to the time. Okay, and number 1, an organism doubles in size every year. If it was originally 3 inches long, how big will it be in 4 years? So we start with the starting number. It says originally 3 inches long, so that's 3. Then it says that this thing is doubling every year for 4 years. Okay, so you can go to Desmos. 3 times 2 raised to the 4th. The answer is that there are 48 organisms in 4 years. Okay, number 2 and 3 says write the equation. So if it's a write the equation, then it's just y equals, because that's an equation. Again, we have a starting number. Write the equation of a squirrel population who had 12,000 squirrels but is declining or decaying 1/4. It doesn't tell me how many years, so I'm going to put the letter X for years. All we know is the initial value, the starting, and the multiplier, the decay number. Try the same thing for number 3. Write the equation. So that's y equals my starting number, my multiplier, raised to the x. So in these word problems, there are no percents, so I didn't have to do a 1 plus or minus. I just got to go straight from the initial value to the multiplier, raised to the time. So in the next type, we do have percent. So if you ever see a percent, I need to turn that percent into a bigger number. So again, we have our starting number, which is the same as the initial value. We have our rate this time, which is our percent. And again, we raise it to the time. Okay, so this one here says write the equation. Whenever it says write the equation, we're going to write y equals. The starting number, the initial value, is $100 in this bank account. Then for 6%, I see a percent sign, so I need a 1. It says it's increasing, so that's plus. 6% is 0.06. I don't know the time, so I'm going to raise this to the x. Whenever it says write the equation, they usually don't tell you the time. So now this is the answer, but we can clean this up. So it's going to be y equals 100. 1 plus 0.06 is 1.06 raised to the x. Okay, number 2, we're actually solving it. So number 2, it says George buys bananas for $4. They gain 2%. How many bananas, what would the value of the bananas be after 3 years? So before we type it in, again, let's clean up the parentheses. So I didn't need a y equals for this one because it doesn't say write the equation. It just says solve it. So I can go right back in and solve it. So 4 is my initial value. 1 plus 0.02 is just 1.02 raised to the 3rd power. So now you can go to Desmos, type that in, and see what you get. When you're ready, try the same thing for number 3. Okay, so on the last page today, we just have practice, star test question practice. For this one here, I'm going to show you how to do it by hand, and then you can use Desmos if you want to. So what we know about an exponential function is that the formula is y equals some initial value times the multiplier raised to the x. So in this one here, y equals, remember our initial value is the same as the y-intercept. The y-intercept is the number with 0. So it's 0.0625. That's my initial value because it's the number with the 0. Then my multiplier, if I figure it out what it's multiplying, I just use my whole numbers. 1 times 4 is 4. So my multiplier is a 4. And then in an equation, we raise it to the x. Which answer choice matches? Letter H. If that's a struggle for you, you can always take the equation, plug it into Desmos. You take the actual equation, then you click the little circle, spiky circle, table, and then you can match your graphs, match your table, see if it matches. So the correct answer is H. Number 2, very easy. Go ahead and try number 2. Number 3, domain and range, not too bad. For this one here, I highly suggest you write D, R. Write it out in regular numbers first, and then figure out which one matches. Remember, range looks like this. Domain looks like this. Okay, try to figure that one out. Next, what is the domain of the graph? We just said that. Last but not least, what is the range? For number 5, you're going to have to plug that into Desmos to see what it looks like, and then you'll be able to figure out what it is. Remember, when we write the range, we don't put a line under our sign because of an asymptote. It's just y is greater than wherever my asymptote is. Okay, not too bad. We have one more day of review tomorrow. Then you'll have your practice test Thursday. Then we all come back Monday. We do one big review, and then you're going to kill it on your test